So my name is Masongsong. I'm the CEO and co-founder of UrbanLogiq. We are originally a Canadian firm, and that's why you're going to hear a Canadian story. But we also have an office in New York City. Our goal is quite simple. I'll go into it in a bit, but our goal is to bring the different data silos from across government to one common operating picture, so that public servants can access all the data they need to make their decisions without having a lot of struggles with extracting data, normalizing it, and then applying data science. Our goal is quite simple. You shouldn't have to be a data scientist in order to benefit from analytics. So UrbanLogiq is a fairly simple concept. So there's more and more data sources becoming available. So 20 years ago there was inductive loops, pneumatic tubes, manual counters. Now there's computer vision, and as you're going to hear today, there's now connected vehicles, location-based apps, cellular data. All these greater data sources are becoming available, and it's only going to accelerate as the advent of the Internet of Things proliferates. For example, in 2017, more data was created in that 1 year than in all of human history combined. The challenge is, as a planner or decision maker, this is oftentimes the reality, and Tyson as a public servant can share with you. These are oftentimes what city planners are left with in terms of how to digest the data sources. So a little bit of backstory. I was actually a public servant in Canada as well, and the frustration I had was we had a $17 billion budget, 105,000 employees, and when we were trying to make a decision in terms of where to put a hospital, for example, we were always told, well, that data is really difficult to get hold of, we'll kind of make a best guess kind of thing. In the meantime, a friend of mine was in a Silicon Valley startup, and they had better access. They could predict down to the postal code how many jacuzzis would be sold. And so it was just a little bit frustrating that, no offense to jacuzzis, but we were doing decisions that had more impact on society. And so we basically made a decision. You quit your job, I'll quit mine, and could we actually bring the best of technology in Silicon Valley and Wall Street into the hands of public servants? So, for example, this is one of our first deployments. This city has 2,700 inductive loops, 320 computer vision cameras, 36 pneumatic tubes. At the end of the day, all you want to know is where's the traffic. So those are the green lines. And then as we talk about today, let's layer on top of that land use, so industrial versus commercial versus retail. How does mobility patterns change based on different types of land? And then on top of that, take it a deeper level, layer all 15,000 businesses. So broken down by industry SKUs, how does a restaurant cause different types of traffic and mobility patterns than a clothing store? And then as you'll see, we'll discuss on the privacy side in a second, let's take it one step further than just vehicle traffic, using location-based data, so cell phone data. For example, can you see those are the bubbles where people are clustering? And then take it one step further than that, let's say just a particular ethnicity, in this particular case, the South Asian or Punjabi community. So this particular city has 44% of their community are South Asians. So the ability to identify where particular communities are aggregating and where they move at different times of day, where they live, where they work, where they shop, and how that's different than other types of other demographics within the city on different times of the day or different days of the week, helps community planners understand the behavioral needs of their communities in a way that you can't really get on a static 5-year-old picture from the census. And I'll point out all this data is our data sources that were readily available to the city before we came to them. They just didn't have a place to layer it all together. Where you can then take the analysis is you can then pick a location. So if you're looking at a particular intersection or a development project, and you can identify a radius, say within 500 feet or 1,000 feet, and just instantaneously pull all the data. So if you're trying to run different scenarios, instead of spending months collecting data, you can just click on it and say, at 8 p.m., what are the transit routes? So you'll notice at 8 p.m. it's only north-south, and how many people of what backgrounds live there, what's the mix of businesses. And it's not just a circle, you can also identify on an irregular shape. So if you're trying to get a sense of, we need to get a sense of if we dig up this road to build a new subway line there, what are the specific businesses to be impacted? It shouldn't take months to do that. That data is stored, if not with you, it'll be with their county, it'll be with your state, and you shouldn't have to then need to go through an arduous process just to answer your own question. Where we have the ability to take it a step further, so this is in Brooklyn, so one of our partners, where using computer vision, you can identify whether the movement patterns on a given intersection. So is it pedestrians? Is it someone in a wheelchair versus someone in a stroller? Is it a senior citizen? If it's vehicles, is it a truck or a car or a bus? How do these mixes change over the course of the day? And not just how many of them there are, what's what's called a footfall pattern. So for example, who uses crosswalks and who jaywalks? One of the things that was found, for example, in certain areas of New York is the most notorious jaywalkers are senior citizens. If you think about it, you'd think they'd be more law-abiding, but in this particular area of Brooklyn, if you're familiar with Folsom Street, if you're a senior citizen, that extra crosswalk is an extra 200 feet away. If you're young and healthy, that's not a big deal, but if you're a senior citizen who has some health issues, that's the difference whether or not you're going to take a crosswalk or step into traffic. And so these are the types of insights that can be pulled. Where you can then map it, and we're quite proud to announce that just a couple months ago, we won an award from the American Planning Association for the system, which takes all of that data and then layered on top of it 70,000 car crash data. And it used machine learning analytics and algorithms to identify what are the attributes, what we call the anatomy of an accident, that causes not just increased volumes of accidents, but also increased severities. So is there a particular part of either this road design or this built environment which is leading to 4 times more fatalities, even though there's not that many accidents? So these are the types of things where these insights can be pulled. And one of the things we found out is we identified certain attributes of the built environment which were 4 times more impactful in severity than a lot of the attributes that the city Vision Zero team was at that time focusing on. You can then take that a step further and, for example, identify not just on a local basis, but on a regional basis. So can you see on this particular road where people are coming from and where they're going to? So everything from road pricing to transit planning. Like if you're in San Jose, how many of your fans for a hockey game are coming from San Jose, or are they coming from Oakland? And what you find out, for example, if it's a Thursday night game, it's almost all local fans. However, it's a Saturday game. People are coming from as far away as San Francisco or the broader Bay Area. So you can better get a sense of who's using your roads and how you might want to optimize your transit capacity. In terms of land use, one of the things that we're excited to do, and Tice will speak more to this in greater depth, is increasingly we can use the data to identify the circulatory system of an economy. So what you're seeing here are Class 8 freight trucks. So we identify, this is now connected vehicle data. These are the transponders in the OBD2 ports. So what we're identifying here is how not the rest of the cars, but specifically freight trucks. How does their movement pattern differ from the rest of the consumer vehicles? And the reason for that is you can then start to see how certain clusters of warehouses and factories are linked. And can you actually reduce the demand in traffic by moving certain pairs of warehouses and factories together? And then finally, where you can, once you have all the data in one place, you can then train deep learning algorithms. So this was something we did in partnership with TELUS, where we combined both public and private data sets across the province and built deep learning as a form of artificial intelligence to predict for every road segment and every intersection across the greater province of British Columbia what their traffic would be, and we made a prediction 4 days in advance across the entire region. And you'll see we have predictions there of speed and volume, and then the government went out there and they decided to test the accuracy of the predictions, and as you'll see, the dotted lines are the predictions of speed and volume, and then the actual results when they tested it, you'll notice were powerfully accurate. And so this has a lot of implications where for smaller communities that may not be able to afford road sensors, using unconventional data, which Sim will speak to next, you can actually infer a lot of traffic and provide the types of analytics that are available to big cities to smaller communities at a lower price point. And in closing, all this sounds exciting, but there are a lot of things that we have to think through if we're going to start using new forms of data and analytics. First of all is the privacy question, of course. Now, there's starting to be some emerging frameworks around this, the GDPR from Europe, the Consumer Protection Act from California. And so I think these are the types of things where, in order for these things to be settled, and first of all, for governments to be comfortable using something, and for citizens to be comfortable with how their data is being used, I think the rules have to be transparent and thoughtful. Secondly, especially in the ITS space, this whole debate around dedicated short-range communications versus 5G and which will win out, I think this is something that a lot of governments are struggling with. Which one do we invest in? We can go into this more during the Q&A, but I think one of the things our our point of view is that it'll be both, because when we look at the data attributes of DSRC and 5G, they're actually different. So it's not going to be one or the other. They're going to be both used for different purposes. The question of data ownership. Does this data belong to the car manufacturer that's connecting vehicles, or does it belong to you as the person who bought the car? Does the government have certain rights to use that data, which, for example, the European Union has decided that they're looking at requiring some of these data to be available for public good uses. Vendor lock-in, obviously as a private sector company, it's interesting for me to bring this up, but one of the things that I think technology accelerates so fast, I would caution governments to sign contracts that don't give them rights to port their data over to someone else, because the best company today may not be the best company 5 years from now. So hopefully governments like our work 5 years from now, but if, for example, there's a better player that emerges, you don't want to have a situation where your transportation models are now held in a proprietary company and you're stuck with that company. And so increasingly what we're happy to do, and we're seeing out there more, is the requirements for data to be ported over to whoever the government wants to work with. There's a joke in the standards community that everyone likes standards, that standards are like toothbrushes. Everyone has them, but no one wants to share. One of the reasons why it's refreshing to be working with transportation engineers is you can drive your car from New York City to Miami, and you know the roads will fit your car, you know the bridges will support your car, and that's because engineers did something very wise. They standardized, road width, they standardized building codes. One of the things why analytics is not, all these exciting technologies are not widely used is because there are not a lot of standards, and so every time the city wants to bring something new, oftentimes governments are inventing things from scratch, and that's increasing the cost of deployment and increasing the length of results. So I think there's a lot of work to be done where public and private sectors and even private sector competitors agree that certain things will be universal standards. And finally, and I'll use the segue to TELUS, which I think is one of the leading players when it comes to responsible use of data, is the question of ethics. Some of our analytics we find are 94, 95, 96% accurate. However, if that's being done through tracking a certain types of data sources within government, or partnering with outside vendors where they are analyzing, so let's say, aggregated and de-identified smartphone data. The question is, certain parts of the population can't afford smartphones. So the very groups of people you might want to be most sensitive to are the ones most likely to be missed. So these are the types of questions that I think that are emerging and have to be dealt with as we go forward.